In this video, we're going to simplify nth roots. In 1, it says given the square root of x plus 1 squared, part A says find the square root of x plus 1 squared when x is equal to 2. So we want to plug 2 in for x. So we have the square root of 2 plus 1 squared, which is equal to the square root of 3 squared, which is equal to the square root of 9, and the square root of 9 is equal to 3. In part B, it says find the square root of x plus 1 squared when x is equal to negative 4. So we're going to plug in negative 4 for x, so we have the square root of negative 4 plus 1 squared, which is equal to the square root of negative 3 squared, and that is equal to the square root of 9, which is equal to 3. And then it asks, what is the absolute value of negative 3? And the absolute value of negative 3 is equal to 3. So part C says, how can you simplify the square root of x plus 1 squared without knowing whether x plus 1 is positive or negative? And we can do that by using the absolute value. So we know that in part A we found that the square root of 3 squared was equal to 3, and in part B we found that the square root of negative 3 squared was equal to 3. So we can rewrite the square root of x plus 1 squared as the absolute value of x plus 1. In number 2, it says given the cube root of x plus 1 cubed, find the cube root of x plus 1 cubed when x is equal to 2. So we plug 2 in for x. We have the cube root of 2 plus 1 cubed, which is equal to the cube root of 3 cubed, which is also equal to the cube root of 27, and the cube root of 27 is equal to 3. In part B, find the cube root of x plus 1 cubed when x is equal to negative 4. So we plug in negative 4. And we simplify that, and we get the cube root of negative 3 cubed, which is equal to the cube root of negative 27, which is equal to negative 3. So in C, it says our absolute value signs needed when simplifying the cube root of x plus 1 cubed. And the answer is no. And now we're asked, how is this different from problem 1? In problem 1, if we look back, we had the square root, and the square root is an even root. And in problem 2, we have the cube root, which is an odd root. So when asked how is it different, we could say that the index is odd in problem 2, and it was even in problem 1. Now we have the definition of the nth root of a to the n. If n is a positive odd integer, then the nth root of a to the n is equal to a. If n is a positive even integer, then the nth root of a to the n is equal to the absolute value of a. In 3, it says simplify, if possible, by completing each step. In A, we have the fourth root of negative 3 to the fourth, and they want us to simplify by first evaluating negative 3 to the fourth, then simplifying the radical. So if we have the fourth root of negative 3 to the fourth. That is equal to negative 3 to the fourth is equal to 81. So we have the fourth root of 81. And the fourth root of 81 is equal to 3. And now they want us to simplify by using the definition of the nth root of a to the n. And if we have the fourth root of negative 3 to the fourth, this is equal to, we have a positive even root and a positive even exponent, and this is equal to the absolute value of negative 3, and the absolute value of negative 3 is equal to 3. In B, we have the fourth root of negative 3 to the fourth, and it asks, how is this different from part A? In B, the exponent only applies to the 3. And not the negative sign. And then it asks, can the definition be applied? And the answer is no. And is the fourth root of negative 3 to the fourth a real number? And the answer is no. Remember, when we apply the exponent of 4 to 3, we would have the fourth root of negative 81. And then we have an even root and a negative integer inside the radical. So it's not a real number. In C, we have the cube root of negative 5 cubed, and we want to use the definition to simplify. And if we use the definition to simplify, we can say that the cube root of negative 5 cubed is equal to negative 5. In D, it says the cube root of negative 5 cubed. And it asks, how is this different from part C? And it's different because the exponent applies only to the 5. So the difference between the two is the set of parentheses. So in C, we have a set of parentheses around negative 5. And in D, we have negative out in front of 5 cubed. So the exponent only applies to the 5 in D, where it applies to the negative 5 in C. And then it asks us, can the definition be applied? And the answer is no. So if we want to simplify, we have the cube root of negative 5 cubed, which is equal to the cube root of negative 125, which is equal to negative 5. In 4, it says simplify each expression. So we're going to use the definitions. So we have the square root of 3x minus 2 all squared, and we're going to say that that is equal to the absolute value of 3x minus 2. And in B, we have the cube root of 3x minus 2 all cubed, and that is equal to 3x minus 2. When we have an odd root, we don't need our absolute value signs. And that's the video on simplifying nth roots.